We often think of scientific breakthroughs happening through sleek, futuristic technology, giant lasers, particle accelerators, gene editing tools, but sometimes the most profound discoveries come from the simplest, even accidental, observations. Think of Galileo with his telescope, revealing the moons of Jupiter, or Marie Curie toiling away in her lab, discovering radioactivity. Today, we're going back to 1964. Two astronomers armed with what might seem like a clunky, old-school telescope stumbled upon a secret, a whisper from the universe itself that would reshape our understanding of its very origins. This wasn't a sleek space probe or a high-powered observatory. This was a telescope that, in a way, could hear the universe. This is the story of how a simple discovery, made with seemingly outdated technology, unlocked some of the universe's biggest secrets. Picture this: 1964, New Jersey, Bell Telephone Laboratories. Two radio astronomers, Arno Penzias and Robert Wilson, are working with a large horn antenna. Now, this isn't your typical telescope peering into the depths of space. This antenna was originally designed for satellite communication. Penzias and Wilson weren't searching for the secrets of the cosmos. Their goal was far less glamorous. They were trying to map radio signals across the Milky Way. But there was a problem, an annoying one. Their telescope was picking up a persistent hiss, a faint uniform static that seemed to emanate from everywhere in the sky. Day and night, no matter where they pointed the antenna, the hiss persisted. They checked their instruments, calibrated them again and again. They even considered the possibility that the interference was caused by something as mundane as pigeon droppings inside the antenna. Yes, really, they cleaned it thoroughly, removing the white dielectric material, their polite term for what they found, but the mysterious signal remained. It was as if the universe itself was trying to tell them something. Little did they know it was. This wasn't just noise, this was the echo of an event so monumental, so fundamental, that it had shaped the very fabric of existence. They had stumbled upon the faint afterglow of the Big Bang. Unbeknownst to Penzias and Wilson, just a short drive away at Princeton University, a group of physicists was working on a theory. They were calculating what the universe might look like if the Big Bang, the idea that the universe began from a single point of unimaginable density and temperature, were true. Their calculations predicted that the universe, still expanding and cooling from the Big Bang, should be bathed in a faint afterglow of radiation. This radiation, stretched out over billions of years, would have cooled down to just a few degrees above absolute zero. It would be almost imperceptible, a faint whisper from the universe's infancy. This theoretical radiation, known as cosmic microwave background radiation, or CMB, is essentially the leftover heat from the Big Bang. Imagine the faint warmth you feel on a brick wall long after the sun has set. It's the same principle, but on a cosmic scale. When Penzias and Wilson heard about this theory, they realized the significance of their accidental discovery. The annoying hiss they'd been trying to eliminate wasn't interference at all. It was the echo of creation itself. This wasn't just an interesting observation, it was a game changer. The discovery of the CMB provided the first direct evidence to support the Big Bang theory. Before the discovery of the CMB, cosmology was a field divided. The Big Bang theory, proposing the universe had a definite beginning, was in a heated debate with the steady-state theory, which argued the universe was infinite and unchanging. The steady-state theory was attractive to some because it avoided the messy question of a beginning. If the universe was infinite and eternal, there was no need to explain how it all started. But the CMB threw a wrench into the steady-state model. The universe wasn't unchanging, it was filled with the faint afterglow of a hot, dense past. A past that could only be explained by the Big Bang. Imagine you're walking through a forest and you stumble upon a perfectly preserved fossil. It's not just evidence that a creature once lived there, it tells you something about the environment, the climate, the history of that forest. The CMB is like a fossil of the early universe. It provides a snapshot of what the universe was like just 380,000 years after the Big Bang. It allows us to study the conditions present in the universe's infancy. The discovery of the CMB tipped the scales decisively in favor of the Big Bang. It wasn't just a theory anymore, it was a reality supported by tangible evidence. The discovery of the cosmic microwave background radiation was monumental. It wasn't the result of a deliberate search, but rather a testament to the power of serendipity in science. Sometimes the universe reveals its secrets in the most unexpected ways. In 1978, Penzias and Wilson were awarded the Nobel Prize in Physics for their discovery. It was a recognition of their persistence, their meticulous approach, and their open-mindedness to acknowledge the significance of what they found. Their accidental discovery had profound implications. It provided the most compelling evidence yet for the Big Bang theory, forever changing our understanding of the universe's origins. It opened up new avenues of research in cosmology, leading to the development of sophisticated instruments designed to study the CMB in greater detail. Today, satellites like Planck are mapping the CMB with incredible precision, allowing us to probe the universe's earliest moments and understand its evolution with unprecedented detail. The discovery of the CMB wasn't just a single event, it was the start of a journey to unravel the mysteries of the cosmos and our place within it. A journey that continues to this day, fueled by curiosity, innovation, and the enduring human desire to understand the universe we call home. Think back to that clunky 1960s horn antenna in New Jersey. It might not have looked like much, but it was able to detect the faintest whisper from the very dawn of time. That discovery sparked a revolution in cosmology. It led to the development of space telescopes like Hubble and James Webb, which have revealed breathtaking views of the cosmos and pushed the boundaries of our knowledge. It spurred the development of theories about dark matter and dark energy, mysterious forces that shape the universe on the grandest scales. It even fueled discussions about the possibility of a multiverse, the idea that our universe might be just one of many, all because two astronomers listened carefully to the universe and heard its faint, ancient echo. This single discovery sparked a whole new era of modern cosmology, leading to Hubble, James Webb, dark matter theories, and even the multiverse concepts we debate today.